The last example has us looking at the exact same region, but rotating it about 4 different things: about the x-axis, the y-axis, the line y equal 2, and the line x equal 5. So we're going to have to determine when we have this region, the region doesn't change, but when we have this region, this yellow region that we're going to draw, are we a disk or are we a washer depending on what we rotated about? And then find again the limits of integration and the radii. Let's go ahead and draw this, and after we draw this, we will look at rotating it. So I'm going to draw y equals the square root of x minus 1. Well, that's just a square root function, but it's moved over 1 unit. There we go. That is the square root of x minus 1. Then we have y equals 0. Y equals 0 is just the x-axis. And then we have x equal 5. Well, x equal 5 is this vertical line. The region that we're looking at is this yellow region right here. Now the region is not going to change when we rotate it about different things. The region is always going to be the same. So we're going to redraw this region for each part that we have in this problem. So part A says the x-axis, so we're going to rotate this about the x-axis. Well, the x-axis is horizontal. Since it's horizontal, that means that we are going to integrate with respect to x. Since we're integrating with respect to x, I need to find the limits of integration in x. Well, are they visible? Yes. Well, I start at 1 and I go all the way to 5, so my limits of integration are going to be from 1 to 5. Then I have to determine when I'm rotating about the x-axis, am I a disk or am I a washer? Well, I'm flush with the x-axis the whole entire time, right? That yellow region is always touching the x-axis. That makes this guy here a disk. Since it's a disk, I'm only going to have a radius squared. Well, what is that radius? Well, that radius is going to equal the green minus the blue, which is the square root of x minus 1 minus 0, or the square root of x minus 1. My radius is going to be the square root of x minus 1, and then I square that dx. Let's square it first. If I square the square root, I just get x minus 1. Integrating, I have x squared over 2 minus x, and that gets evaluated from 1 to 5. Plugging in the limits of integration, 5 squared over 2 minus 5 minus 1 squared over 2 minus 1. Grabbing a calculator to work that out, we're going to say alpha y equals and do 5 squared divided by 2 minus 5 minus, open a parentheses, and 1 squared is just going to be 1 over 2, and then minus 1. Closing that parentheses and hitting enter, and we get 8. So my volume here is going to be 8 pi. That's part A. Let's do part B. Part B has the exact same region, so I'm going to go ahead and draw the region again. It is this square root function. It's going to be the x-axis, the line x equal 5. This is then my region. Now what I need to do is I need to determine what I'm rotating about. Well, part B is the y-axis. If I'm rotating it about the y-axis is vertical. If it's a vertical axis of revolution, I know I need to integrate with respect to y. So I need the limits of integration in y. Well, can I see the limits of integration in y? Well, I definitely see y equals 0 here. But the other one is wherever the green and the orange intersect. If I have y equals the square root of x minus 1 and x equal 5, well, the square root of 5 minus 1 is going to be the square root of 4 or 2, so I can definitely see that's y equal 2. So I have my limits of integration. I have to figure out, am I a disk or am I a washer, and then what are my radii? This is definitely going to be a washer because I'm not flush with the y-axis. So I'm going to have to find an outer and an inner radius. But since I need to integrate with respect to y, I have to solve this guy here for x because I need it as a function of y. If I have y equals the square root of x minus 1, squaring both sides, I get y squared is equal to x minus 1. Adding 1 to both sides, I get y squared plus 1 is equal to x. So I know that this green function as a function of y is just y squared plus 1. Now let's go ahead and find that inner and outer radius. So the furthest I am away from the axis of rotation for that outer radius is all the way to the orange line. So that outer radius is going to be orange, which is 5, minus the y-axis, which is 0, or just 5. The inner radius is going to be the green, which is y squared plus 1, minus the y-axis, which is 0, or just y squared plus 1. So here my volume is going to equal pi times the integral from 0 to 2 of outer radius squared, in this case 5 squared, minus inner radius squared, in this case y squared plus 1 squared dy. Squaring both of these, we have 25 minus, and this becomes y to the 4th plus 2y squared plus 1. If I distribute the negative and combine like terms in the same step, I end up with, well, 25 minus 1 is going to be 24 minus y to the 4th minus 2y squared. Integrating this now, we end up with 24y minus y to the 5th over 5 minus 2y cubed over 3, and this gets evaluated from 0 to 2. Plugging in those limits of integration, 24 times 2 minus 2 to the 5th over 5 minus 2 times 2 cubed over 3, and if I plug in zeros for all those y's, that's just going to be a 0. Grabbing the calculator to put those numbers in, we'd have 24 times 2 minus, and then alpha y equals, hit enter, 2 to the 5th divided by 5, and then minus alpha y equals 2 times 2 cubed divided by 3. Hit enter, and you get 544 over 15, so my volume here is 544 over 15 pi. Part C is going to have the same region, but for part C, our axis of revolution is y equal 2. So let's go ahead and redraw the region and then put in the axis of revolution. Part C is the line y equals 2. Drawing this again, we have the square root function, the line x equals 5, and then the line y equals 0. So it's this yellow region again, and we're rotating this about y equal 2. So we're rotating it about this line here. Well, this is horizontal. Since it's horizontal, I know I need to integrate with respect to x. Am I a disc or am I a washer? Well, I am not always flush with this line, so I know that I'm going to be a washer. I'm going to have an outer radius and an inner radius. Can I easily see the limits of integration in x? Absolutely. They're the same as they were before, from 1 to 5. Now I need to find that outer radius and that inner radius. If I make this bigger, the outer radius is going to be the furthest you are from the axis of revolution. Well, that's going to be all the way down to the blue line. So my outer radius here is going to be the axis of revolution, which is 2, all the way down to the blue line, which is 0, and 2 minus 0 is just 2. My inner radius is going to be from that axis of revolution, which is 2, minus the green, and that green is the square root of x minus 1. So now it's time to put those in. So we say outer radius squared, 2 squared, minus inner radius squared, 2 minus the square root of x minus 1, squared dx. Now for this 2 minus the square root of 2 minus 1, I'm going to go ahead and write it twice over here so that it's easier for us to visualize when we're foiling, and then I'm going to erase it from over here. If we square things, well, 2 squared is 4, and then I'm going to get minus, well, 2 times 2 gives me 4 minus 2 square roots of x minus 1 minus another 2 square roots of x minus 1 is going to be minus 4 square roots of x minus 1. And then negative square roots of x minus 1 times the negative square roots of x minus 1 is just going to be x minus 1. Distributing, well, this 4 and that 4 are going to cancel. And that's going to be 4. I'm going to rewrite that as x minus 1 to the 1/2 power. And then that minus is going to make that a minus x, and that minus is going to make that a plus 1. Now for this portion right here, I'm going to need a u sub to do it. So I'm going to split this up into 2 separate integrals, but we don't have to split it up into 2 separate integrals if we don't want to. I'm going to pull out the 4 and just look at this as the integral from 1 to 5 of x minus 1 to the 1/2 dx. And then over here, pi times the integral from 1 to 5 of a negative x plus 1 dx. Here, if I'm using a u sub, if u is equal to x minus 1, your du is equal to dx, which is perfect. That's what you have. So this is really the integral from x equal 1 to x equal 5 of u to the 1/2 du. Over here, if I go ahead and integrate, I'm looking at negative x squared over 2 plus x, and that gets evaluated from 1 to 5. Integrating over here, well, that's going to be u to the 3/2 divided by 3/2, but since that's a fraction, I'm going to multiply by its reciprocal, 2/3. And again, that gets evaluated from x equal 1 to x equal 5. If I plug in these limits of integration, I have negative 5 squared over 2 plus 5, and then minus negative 1 squared over 2 plus 1. And we'll put that in a calculator in a second. Here, I can combine 4 pi and 2/3, and I get 8 pi over 3. And if I get out of u's and go back into x's, I get x minus 1 raised to the 3/2, and this gets evaluated from 1 to 5. Let's put this portion right here into a calculator. So if we're putting that portion right there into a calculator, I have negative and then alpha y equals, enter, 5 squared divided by 2 plus 5. And then minus, open a parentheses, negative alpha y equals, enter, and that's just going to be a 1 over 2 because 1 squared is 1, and then plus 1. Close the parentheses and hit enter, and that's just going to be negative 8, so that's going to be a negative 8 pi. Now plugging in over here, plugging in a 5, I have 5 minus 1 or 4 to the 3/2. Plugging in a 1, I have 1 minus 1 or 0 to the 3/2. So now I just need to figure out what is 4 to the 3/2 times 8/3. 4, raise that to the 3/2. I'm going to multiply this by 8 divided by 3. And we have to take that number and subtract 8 from it because we're subtracting off that 8 pi. If we make that into a fraction, we end up with 40 pi over 3. So my volume there is 40 pi over 3. Our last and final one, Part D. Well, Part D is asking us to rotate this about the line x equal 5. So we need it about the line x equal 5. Well, x equal 5 is vertical. Since it's vertical, we know we have to integrate with respect to y. Let's go ahead and draw the exact same region. Remember, the region doesn't change when you rotate it about different things. The region stays the same. The only thing that changes is what you rotate it about. So this yellow region remained the same for parts A through D. Well, now we're rotating this guy here about this line, x equal 5. Well, am I a disk or am I a washer? Well, this is definitely a disk because I'm touching x equal 5 the whole entire time. Since the axis of revolution is vertical, we're integrating this with respect to y, which means that this curve right here, instead of thinking of it as y equals the square root of x minus 1, I had to think of it as x equals y squared plus 1. So now let's find the radius here because we know our limits of integration. We found those before. It was from 0 to 2. So from 0 to 2. Now we have to find that radius. So remember, the radius is always going to be perpendicular to the axis of rotation. So it's going to be this guy right here. My radius there is, well, it's 5 minus y squared plus 1 because it's the axis of rotation 5 minus the green thing, which is that y squared plus 1. If we distribute there, we end up with 5 minus y squared minus 1, or that my radius is 4 minus y squared. So here I write 4 minus y squared, and I square it dy. Now we want to square this. If we square it, we end up with 16 minus 8y squared plus y to the 4th. Remember, write it twice in FOIL if you need to make sure that you don't make any mistakes. Integrating this, we have 16y minus 8y cubed over 3 plus y to the 5th over 5, and this gets evaluated from 0 to 2. Plugging in those limits of integration, we get 16 times 2 minus 8 times 2 cubed over 3 plus 2 to the 5th over 5. And if I were to plug in a 0, then we just get a bunch of zeros. Putting that into a calculator, we have 16 times 2 minus alpha y equals for a numerator and denominator, 8 times 2 to the 3rd divided by 3 plus alpha y equals for a numerator and denominator, 2 to the 5th divided by 5. We hit enter and we end up with 256 over 15 pi. That's it for volume the disk method.